Here we go. Today is Sunday, March 13th, and this is episode 264 of the Defensive Security Podcast. My name is Jerry Bell, and joining me tonight, as always, is Mr. Andrew Callett.
Good evening, Jerry. How are you, sir?
Doing great. Have a good view.
Yeah, you're at the Southern Command today.
That's right. DefSec Southern Command.
In sunny Florida. We won't go further than that for security purposes.
I can see water. I'll just say that.
That does narrow it down.
To like 2,000 miles.
But no, it looks like a lovely place to be, and I'll be there in 4 hours.
Good deal. It's a little warmer than where you're at, but not a lot.
Mm-hmm. True. But you have, lovely view, as you said.
I do, and I have my cat and my dog and my kids.
And most of those are good things to have.
That's right. That's right. Just a quick reminder that the thoughts and opinions we express on the show are ours and do not represent those of our employers. And I guess, since we've been off for the past 2 weeks, obviously the world's kind of gone to hell in a handbasket. And I think most of the known world has been trying to figure out how to limit the risk of Russia, Belarus, and Ukraine. So I don't intend to spend much time here talking about that. I think everybody's probably sick of it.
The only thing I will say is I think everybody wisely and correctly predicted a large amount of cyber attack activity in conjunction with the kinetic war, but it hasn't seemingly materialized. And that, I think, is interesting. I think we all in our line of work expected a lot more fireworks and that we haven't seen. And I don't know, it's weird. I think I don't think the predictions were unwise. They just so far appear to have been incorrect.
Yeah, so far. I mean, it is still somewhat early days in the conflict, and when we look back at what happened previously with NotPetya, that's I think kind of the worst case scenario that everybody's thinking about again. If we allow endpoints from unwashed or unmanaged third parties into our environment, that can be a gateway into our networks for something again net new like NotPetya was. So we haven't seen it on the scale of NotPetya. I would say that if you talk to a lot of the security companies, there's certainly a lot of activity happening in the Ukraine, but it's not kind of spreading far and wide.
Yeah, and who knows what we don't know, right? There's probably a lot of stuff that we don't understand or aren't hearing.
Sure.
The people who know aren't necessarily talking. There, in theory, I'm told, was a whole lot of prep work that Western nations did in Ukraine leading up to this for a cyber defense standpoint. I don't know. I feel like what we all thought was going to happen hasn't happened, so now I feel like I'm on thin ice trying to prognosticate around the future of that conflict. But
yeah, the situation in Russia though is quite interesting. The segmentation of the internet, not necessarily from a political standpoint. That's not my area, but just watching what's happening with the internet has been fascinating. With Russia standing up its own TLS certificate authority and forcing all .ru domains onto a government. I guess it's a government administered name server set of name servers, and then lots of the major internet properties are either being kicked out or pulling out. At what we saw, backbone provider Cogent back out, and then interestingly, Akamai and Cloudflare have both recently, so far, said that they're not going to back out of Russia. So interesting stuff. And by the way, there's a fascinating article. I don't have it linked for this show, but there's a fascinating story about what Cloudflare is doing to minimize their risk about they're not storing customer encryption keys. They're actually they've created this concept of session keys that are stored ephemerally on systems in the region, and they've actually got them set up so that if anything happens, they lose internet connectivity or they lose their power. When they come back up, they're bricked.
Interesting.
So some creative stuff going on in the world right now.
Well, we don't get into politics here, and we're certainly not going to do it now, but it will be, I think a lot of interesting lessons will be learned long-term from this sort of situation.
Absolutely. All right. Well, we do have a couple of stories. The first one comes from Bleeping Computer, and this one is, it's a small one, but it's indicative of a trend I'm seeing, and I wanted to call it out. It comes from Bleeping Computer. Title is Adafruit discloses data leak from ex-employee's GitHub repo. And what happened here is a former Adafruit employee had been maintaining their own GitHub repository, not as part of Adafruit's corporate repo, but in the public GitHub space. And, conveniently for the developer, I suppose, they had been using actual customer data. And some amount of that customer data actually wound up in this ex-developer's GitHub repository, just freely available to download. This is a trend I'm seeing, not necessarily in this specific set of facts. I've not seen too many cases of actual personally identifiable information being stored in GitHub repos, but we are starting to see things like access tokens and passwords and whatnot with more and more frequency, where in particular a lot of companies have this concept of an internal GitHub repo, which is access controlled, only available to customer, I shouldn't say customer, but company employees and whatnot. But they're also kind of fostering this participation in open source and whatnot. And so my perception is that we're going to see a lot more of this because people, right or wrong, I think sometimes have struggle with the idea of separating between company, especially if they're both GitHub, right? Between company and personal or public. That, by the way, completely ignores the fact that developers shouldn't have access to production data, which is, I think, something that fell apart in this particular case.
Yeah, I mean, the circumstances of how the data was disclosed or stored is different, but this is an age-old problem of devs needing or wanting examples of production data for their projects, and companies struggling to build a representative data set out of fake data that serves the needs of the developers. It's a very common problem. Seen it throughout my entire career. This is different in that now it's pushed out to GitHub. And this is an interesting information disclosure sort of problem, because you're right about GitHub having this weird potential blurry line between what is the enterprise repo, what's a personal repo, are they coming in with it with their personal account and attaching to the enterprise repo? There's a whole bunch of nuance there. And does a corporation have the right or the need to see what's in their employees' personal repos to try to limit information disclosure or this sort of problem. It's a tough challenge, but you're right. We're seeing more and more leaking of information via repos, and I think that in part is because that's how modern development is done. But it also seems like we're not being as careful with secrets and API keys and that sort of stuff that we probably should be in the way that the developers are using it because of convenience and fast dev time, turnaround times, and just the way modern development cycles work for a lot of companies.
Yeah, definitely. The other big issue, I think, where Adafruit fell down, other than making sure that developers don't have access to production data or live data, and then also not posting it publicly, is that after they made an announcement that this had happened, they publicly stated that they weren't going to be, based on a threat analysis, they weren't going to be notifying the people who were impacted, so whose personal information were posted in the in the public repository. And they took a lot of hell for that, which is surprising because Adafruit is generally pretty otherwise progressive company. So I was pretty surprised to see that.
Surprised that they took hell, or that they chose not to email folks?
That they chose not to email people.
Yeah.
Sorry.
Yeah. Well, I mean, they came out with a bit of an explanation. They heard the feedback from the community and like, we screwed that one up. Okay, we're going to do that. And, they kind of had this explanation. We did what we thought was best, right? So maybe they just listened to some bad advice. I don't know.
Yeah, I mean, they did obviously quickly course correct, and they didn't, they didn't pick a bad hill to die on. So
right.
give them credit for that. But this is why we all have jobs, right?
Yeah.
Security is hard, and this is an opportunity for us to learn from. I think that unfortunately, if I kind of decompose what happened, a lot of this I think does come down to behavior, right? Especially when you're thinking about public GitHub versus internal GitHub. That is a bit of a behavior thing. It's going to be difficult to implement technical controls there. On the other hand, though, it is, it is a pretty cut and dry access control philosophy that would restrict developer access to data. Now, having said that, if I don't know a whole lot about Adafruit in their organization, right? If they have 10 developers and that's their IT team, you're probably not going to implement that kind of hard and fast segregation. But otherwise, I think that's the next layer of defense.
Yep.
All right. So moving on to our next story, which also comes from Bleeping Computer. The title here is Malware Now Using NVIDIA's Stolen Code Signing Certificates. So not too long ago, NVIDIA was the victim of a ransomware attack, this type of which involves stealing data. Apparently they had about 1 terabyte of data stolen, which included two expired code signing certificates. And one of those certificates expired, I think it was 8 years ago. The other expired 4 years ago. Now, but the interesting thing is that though they're expired, Windows still honors code that's signed with expired certificates. And the reason is that let's say you, as a consumer, go buy or pull out of your junk bin, a 5-year, 6 or 7 or 8-year-old video card, and you slap it into your computer, and you need to install some drivers. If the drivers for that video card haven't been updated in 5, 6, 7 years, the code signing certificate for that driver is almost certainly expired. And likewise, if the manufacturer of that card goes out of business, well, there's certainly not going to be any more currently signed drivers. So it's by design. Windows, and I think some other operating systems too, do accept code code signed with expired certificates, which is problematic here because now we have a situation where certificates are in the hands of adversaries who are actively signing malicious code, which has the implication of if the adversary is able to get that code onto a computer, they're able, it can be installed without a lot of hoopla.
Yeah, it's almost like we need a third option for code signing verification, which is not good, bad, but known to be maliciously used.
Right.
Use caution.
Right, like a reputation.
Yeah.
Certificate reputation. That's not a bad idea. So it's not just a binary thing. In the article, they actually give some guidance released by Microsoft on how to block these specific code signing certificates, but it is not easy, and I think it's I would say nigh impossible for like more of a consumer type person.
Yeah, that's fair. But it might help corporations or enterprises or, I don't know. I mean, the whole point of being able to revoke a certificate is something like this. And if we're not going to revoke a certificate when it's being used maliciously because we're worried about bricking other things, what's the point? Like, when are you willing? Is there a period of time that you'll add it to your revoke list? I don't know. I'm a little frustrated with the box they've gotten themselves into with this situation.
Yeah, there's not a lot of good options here, other than to follow the guidelines that were provided by Microsoft. It sounds like at some point in the future, Microsoft may revisit their decision to blacklist these two certificates. So moving on to our last story for today. The title here, this one's from ZDNet. The title is an NSA report. This is how you should be securing your network. So the NSA, for those of you who aren't familiar, the NSA and CISA have been...
If you're not familiar, I'm sure they're familiar with you.
Yeah, I'm sure they're quite familiar with you. Absolutely.
Sorry.
They've been releasing some. I assume they're trying to keep up with the Joneses in the GCHQ in the UK and the ASD down in Australia, who have been like super thought leaders in security. The NSA actually is now releasing quite a lot of guidance at a bit of a fever pitch recently. This new document is, I'll say it's kind of interesting, and I think you characterize it as a bit of new and a bit of old when you first sent it to me. And after having read it, a couple of observations. Number one is it's highly Cisco centric.
Yeah, it almost feels like, hey, for this particular network design with this particular gear on these particular versions, what should we configure?
It's very, very highly Cisco centric, and it is it's fairly basic too. It occurred to me that most of the stuff here you would learn through some basic Cisco security education. But having said that, it comes from a reputable source. It's kind of like hiring a consultant, right? Somebody more important and authoritative is telling you how you should be doing things. There are, I would say, the one surprising thing in here. There's not a lot of surprising things in here. The one surprising thing for me in here was the high amount of specificity they gave to VPN configuration. And
yeah, it felt like somebody said, here's a very specific network environment.
Right.
What are the best practices for this particular situation? Which is fine, but it's not very generically useful information for anybody else.
Yeah, it goes from some very fluffy statements like I've complained about in the past, where at the very start of the document, it talks about how you really should only allow network traffic that is specifically required to accomplish the mission of the network, I think is what they said. But, one of the challenges, like I've been doing IT stuff for damn near 30 years now, maybe longer. And one of the challenges you often run into is, well, my application requires all the high ports.
Right.
Right. Bidirectional. Okay, well, UDP, I mean, it's a requirement. TCP. What can we do? Right.
Some other protocol we've never heard of, just everything. Just turn it all on.
What can we do? Right. I mean, it's required. I was told it's required. What can we do? That is, I think, part of the challenge that gets us into trouble is we make trade-offs a lot of times without even understanding that we're making trade-offs, because we don't deeply understand some what those trade-offs are, right? Whereas we should be thinking about how to minimize the threat space down to next to nothing, and then figure out how to make our applications work with that, rather than the other way around, right? We start with the list of required ports and protocols and whatnot, and for any given application, and I think that gets us into some trouble. And I've talked about it in the past about how it's enabled tunneling, kind of free and easy tunneling between otherwise restricted network between domain controllers, and so on.
But the sad reality is when you go to an application owner or whomever's making a request for whatever network configuration they want, and you ask them, what exact ports and protocols do you need? They can't answer that question 9 times out of 10.
Well, if they can, it's out of the manual of or off the FAQ page of the software provider.
I mean, you and I ran a network together a long time ago that we were very particular about the firewall rules, and we forced that kind of, you have to tell us exactly what it is, and we tightened it down as hard as we could. The problem with that is it slowed everything down. It took a lot of effort, a lot of smart people's time. It's very secure, but it probably is way too slow for the average business, and it just isn't viable for most organizations. At least currently today, there's not this push to say, give me very detailed information of exactly what you talk on. And when I say talk on, I mean ports, protocols, that kind of thing. I think so many network folks or security folks have just gotten away from that question. Even the vendors don't tell you, or they don't know. So I don't know. I feel like we've lost that battle, I guess is where I'm going with this.
Yeah, but that's the trade-off, though, right? I mean, it's just another example of the trade-off between speed and security, or labor.
Yeah.
Labor and security, and ideally we would find a better way, but I think given the constraints of how IP works and how applications work and how firewalls work and whatnot, I think we're in a bit of a tight spot, and either we end up on, the really hyper restrictive, going to be slow side, or we're too permissive, and that is so anyway. It was interesting to contrast that fuzzy abstract guidance with, in the VPN section, only use UDP, ESP, based VPN protocols. Like only use UDP 4500, and use these very specific algorithms. And it was a kind of an interesting dichotomy between the two bits of guidance. It probably relates to maybe their level of expertise, right? They're maybe not so expert in kind of the consultative aspect of network design, but more in the system configuration.
Yeah, it felt like somebody just copy pasted an SOP of how they set things up.
Yes. They have a set of of standard configuration standards, and they did some copy paste, like you said.
Yet, let's not even think about, the vast majority of companies are now doing something in the cloud.
Yeah. Yeah.
Anyway, it was just a really weird. I expected it to be a lot more useful to a lot more companies than this was. So I don't know.
It seemed very useful. And one other interesting thought they had, which I thought was actually a good idea, and that was putting if you're not able to do if you're not able to restrict the other end VPN endpoints, so where the VPN connections are coming in from, if you're not able to restrict that to a set of known IP addresses, they recommend putting IPS devices in front of your VPN endpoint, which is not a bad idea. And the intention was to look for attacks against the protocol attacks against the VPN, which I guess makes some good sense. Although, again, I've done this kind of thing for a long, long time, and unless IPS technology has come a long way, I've never actually seen an IPS be able to provide deep insight into attacks on VPN endpoints like that.
Yeah,
upper layer VPN attacks.
Unless you have a really weak VPN.
Well, yeah, I suppose. Well, it's really their recommendation is looking at protocol negotiation attacks, which you conceivably you would be able to see outside of an encryption stack, but I think that the problem is that's fairly nuanced. Like you would have to have an IPS has that capability. I don't think you're going to be able to slap any IPS in there and get that done. Now, the one thing that they didn't have, which I thought that they should have had, is port isolation, because they have a whole section on configuring ports, and it talks about disabling dynamic trunking and port security and VLANs and network access control and turning off unused ports and disabling proxy ARP and whatnot. But they don't talk about port isolation, which I thought was interesting.
Yeah, I also thought it was interesting that they suggested a password of NSA backdoor to all of your stuff.
I was half thinking that to say there's two versions of this document. There's one for U.S. companies and one for non-U.S. Anyway, it's a interesting document, and I would say it's just one of a library of documents that the NSA is starting to put out, and so maybe in the future there'll be another version for Palo or whatever, but this is it. It is interesting because it's a very old school IT centric, I guess. I think that's what I've been trying to have. I've been having a hard time putting my finger on what is the consternation I have with it. And I think it's just that it's old school IT.
2003 called. They want their advice back.
Maybe so. Anyway, I don't want to discourage agencies like the NSA from trying to help companies and organizations be more secure. I think this is good stuff. It would be super helpful to see some things like this for modern IT, I guess is the best way else I can say it.
Fair enough. Yeah.
All right. Okay. Well, the beach is calling, so I think I'm gonna.
Jerry, are you hearing voices again?
Well, yeah.
It's all right. We'll get you.
I wouldn't say. I don't know that it's again. Maybe still.
That's fair. If you don't argue with the voices, it's much easier.
That's true. But then then you're just ignoring them, and they don't like that. They really don't.
And on that awkward note,
thank you everyone for listening. You can follow the show online at defensivesecurity.org. You can find all of our back episodes. You can follow Mr. Callett on Twitter at Lurg. You can follow me on Twitter at MaliciousLink. And with that, we will talk again soon.
Thanks, everybody. Have a great week. Bye-bye.
Take care.